In this, we will understand about how do we find the confidence interval for a population mean when the sample size is large and the population standard deviation is unknown. So more or less, it will be similar to the previous one, except that instead of sigma, we'll be replacing it with capital S, which is the sample standard deviation. So here, the interval estimate of a population mean when the sample size is large, that is n is larger than 30, with the confidence coefficient 1 minus alpha, and sigma is unknown, is given by x bar plus or minus z capital S divided by root n, where this x bar is the sample mean, z is the z table value for a standard normal distribution when for a given particular confidence level for a two-tailed test, and S is your sample standard deviation and n is your sample size. Let us do this question. A random sample of 50 sale invoices was taken from a large population of sales invoices. The average value was found to be rupees 2000 with a standard deviation of rupees 540. Find a 90% confidence interval for the true mean value of all the sales. So here our sample size is given as 50 and was taken from a large population. Of course, 50 is large and the average value was found to be 2000. That means X bar is 2000 and the sample standard deviation S is given as 540. Here they are talking about a 90% confidence interval. So which means we should consider Z value for 90% confidence is 1.645. Therefore, confidence interval will be X bar plus or minus Z times S divided by root n, which will give us 2000 plus or minus 1.645 times 540 divided by root of 50. So if we calculate this, we will get 1.645 into 540. That we will get 888.3 and the root of 50. Square root of 50 is 7.07. So this will give us 2000 plus or minus 125.62. Therefore, confidence interval will be, first of all, we will subtract and see what is the lower limit. It is 1874.38. Upper limit, simply add 2125.62. So this will be the limits, confidence limits for the given for the population mean. Let us move on to the next one. A random sample of 100 observations, which means n is 100. It is a large sample. Yields a sample mean as 150. Sample variance as 400, which means our S will be 20. Compute the 95% and 99% confidence interval for the population mean. For 95% confidence, Z will be 1.96. For 99% confidence, Z will be 2.58. So let us continue in the next. So now confidence limits will be, or confidence interval will be X bar plus or minus ZS by root n. First one, for 95% confidence, let us calculate this. X bar, let me substitute the values now. X bar value is known to be 150. So confidence limit will be 150 plus or minus Z, which is 1.96. Yes, I think it is 20. Yes, it is 20 divided by root of 100. Root of 100 is 10. So we will get 150 plus or minus 196, 1.96 into 2, which means we get 3.92. So therefore, confidence interval lower limit by subtracting these two, we get 150 minus 3.92, we'll get 146.08, and upper limit 153.92. This is about 95%. Next, they have asked us to find out for 99%. 150 plus or minus, that is 2.58 times 20 divided by 10. That will give us 150 plus or minus 2 into 2.58. We get 5.16, which means our confidence interval will be, by subtracting, we get the lower limit 144.84. Adding, we'll get the upper limit 155.16. That is the solution for this particular problem.